Hello everyone, in today's video I will be starting a new topic called conjugate beam. So here first I'll write the definition of the conjugate beam, that is conjugate beam. I'll write here in short, that is CB. Okay, so now conjugate beam is defined as an imaginary beam having length equal to the length of actual beam, loading as M by EI diagram of loaded beam, but the changes in support condition according to the rule. Okay, so now here the conjugate beam is a imaginarily beam having the length equal to the length of the actual beam, loading as M by EI diagram. So what is M by EI diagram? In my previous video also I have already mentioned about this. So in my previous video I have I took the moment area method, and in that method also we have used the M by EI diagram. So suppose what happened, it's a cantilever beam where a load is acting and a load of W, and the length of this one is L. So now the main thing here is to find the bending moment diagram initially. So what will be the bending moment diagram here? It will be 0 and something will be like this. Okay, so this is the bending moment diagram. So now again we have to draw the bending moment M by EI diagram. So M by EI diagram is nothing but it will be same as bending moment diagram, just we have to divide this term with BMD diagram by EI. Just we have to divide with E by I, and EI is nothing but it's a constant term. Okay, suppose EI value is given in the question, then we can put the value of EI in this term and we can identify the value for I. Okay, value for this length. So now this is the M by EI diagram. Here M by EI diagram I'll write. Okay, so now in the definition what it says, that it is a imaginarily beam having length equal to the length of the actual beam. Actual beam here is this one. Okay, this is the actual beam, and the length will be equal to the length of the actual beam. Okay, this is a imaginarily, suppose, and this is the actual beam. So the length will be same as the actual beam of M by EI diagram of beam loaded, but the changes in support condition according to the rule. So we have some rule in case of the conjugate beam. So here suppose see, in this case what happened, the fix is in this end, right? So the M by E diagram will be same, and here before it was fixed this side, right? But in case of the conjugate beam, what happened, the fix will be in this side. So there are some rules in case of conjugate beam. So I'll go through the rules of the conjugate beam in detail. So this is the conjugate beam. Okay, conjugate beam for this type of beam. Now I'll write some of the important points which we need to remember in case of the conjugate beam. Okay, so now I'll write like this: important points to remember. I'll make the table first. I'll write here. Okay, so given beam versus conjugate beam. I'll make a table of both. So in the given beam, the first is suppose here for a hinge support. So in the conjugate beam, the support will be same. Okay, and in case of the roller support, the conjugate beam will be same as the given beam. Now in case of the fix, and what will happen in the conjugate beam, this side will be free and the fix will go to that side. Okay, in case of the conjugate beam, it will be change. Now suppose some internal supports, this is nothing but the internal support, internal support. So in the conjugate beam, what happened, this internal support will change to a internal hinge. Okay, and again, if some internal hinges are given in the normal beam, then in the conjugate beam, it will get changed into a internal supports. Sorry, this one, internal support. Internal supports. Okay, so these are very important thing to remember in case of the conjugate beams. Okay, now I'll write down some of the steps which we needs to follow in conjugate beam method. Okay, so conjugate beam method. In this method, we have to follow some steps. The first one is to make a BMD of a given beam. So BMD is nothing but the bending moment diagram. And the second is to draw a M by EI diagram. And the third step is to draw a conjugate beam. And the fourth step is to, if here this conjugate beam is also used to find the slope and deflection, and here to find the slope, we have to calculate the shear force of conjugate beam. Okay, and the last step is to find the deflection. Find the deflection. And to find the deflection, we have to calculate shear force, bending moment. Okay, here bending moment of the conjugate beam. So these are the 5 steps which we have to follow during conjugate beam method. Now I'll highlight some of the most important things which needs to be remembered. So important, I'll write it like this. Okay, important. I think I have mentioned in my previous videos also, but again I'll repeat here. So suppose if our bending moment is like this. Okay, so like this, then here the distance will consider as A and B, and the whole distance will consider as L. So, and this is the H height. Okay, so now to find the CG, here for this type of beam, the formula is B plus L by 3, and for this side A plus L by 3. and to find the area of this type of beam is 1/2 into base into height. So this is the height, this is the base. Okay, now here area is half. So what we have done here is we have taken this part. Okay, so this is the shape of a triangle, right angle triangle. So the formula of right angle triangle is nothing but half into base into height. This is height and this is base. So this is the formula. Okay, now second case is it will be same. Like if our bending moment is like this, then area can be determined by this formula, half into base into height. So this is base, this is height. Okay, and here, as I've already mentioned in my previous video, CG will act at the center. CG is nothing but the center of gravity. So from this end, if we find the CG distance, then the formula will be 2/3 of L, and this distance will be 1/3 of the L, 1/3 of the L. Okay, now here if our bending moment is like this, it's in a parabolic. So let it be H and this is be the L. Okay, so our CG will act at the center. So now area, to determine the area for this type of bending moment diagram, the formula is 2/3 of H into L. Okay, here what we have to do, we have to draw a imaginary line and see this part is equal to this part. So this is the formula for this shape. Okay, now again, if our bending moment diagram is like this, it's like this and it's a parabolic. Okay, so here the area formula will be 1/3 of H into L. This is H and this is L, and CG will act at the center. And to find the CG distance, we have a formula that is from this side is 3/4 of L and from this side is 1/4 of L. Okay, and here, and the last thing is if our bending moment is like this, okay, like this, then we'll consider this as B and this as A. This is A. Okay, so now, and this is H. Okay, so to find the area, we have a formula that is A plus B divided by 2 into H. And to find the CG will act at the center, and to find the CG distance we have a formula that is A plus 2B divided by A plus B into H by 3. So we have to remember all those formula for different cases, and these are the most important things which we have to remember. Okay, so these are the formula which I'm highlighting. Okay, so these are the most important things which we have to remember, and it will be used in so many cases, not only in case of the conjugate beam, but it will be used in moment area method, for a slope deflection method. So these are the steps which we have to follow to find the slope and deflection of a conjugate beam, and this is the steps which needs to be followed in case of the conjugate beam method. And these are some of the conditions which we have to remember in case of the conjugate beam. Okay, thank you.